All right, hello and welcome to another video. In this video, we'll be going over how to process spectroscopy data with JMP. Specifically, how do we take the data we get from our Vernier LabQuest 2s in lab and turn that into usable graphs? And then can we label our peaks on there or color ranges, and can we use value ordering and colors to format our graphs? So I think this one will be very practical. On your LabQuest, when you get out that data, it'll give you like run wavelength, run wavelength, run wavelength, run wavelength for all of them. I like to relabel these directly in the CSV to whatever the run corresponds to. So it's a little abstract right now, but when you run these in lab, you'll understand what I mean. So usually my first trial is a blank, and then these are pigment extracts. So I have my first fraction, second fraction, third fraction, fourth fraction of stuff coming off a column, all the way up to fraction 7, it looks. Wow, don't know why I picked this one, but I did. Um, so I want to get this into JMP. Let's just start from the beginning. So I'm going to put all of this on my clipboard. I'm going to go to my new table, click edit, paste with column name. Now I've got my wavelengths, my fractions in here. Now you might be annoyed that my wavelengths all have different column headers, but this doesn't matter, and here is why. We're going to stack our data. But we're going to do a special stack this time. So we do table stack, we select everything, we stack it, and we're going to do a series stack. So I have two series here, 1, 2. I want to stack all my wavelengths with all my wavelengths and all my runs samples with all my samples. I don't want contiguous. If I had, like, say, all of my wavelengths and then all of my fractions, I would click that, but let's just leave it. I'm not going to bother typing in stuff here. I don't normally bother anyways. I think it's confusing, it's obvious in hindsight, and in this case, it doesn't even work uh, for reasons we'll get into later. And we'll just leave the rest of it. All right, so here I have a wavelength label column. I don't need it, so I'm going to delete that. So this is what matters. This is my wavelength, nanometers. This is my sample, and this is my absorbance. Now I'm going to take these, plop them into Graph Builder. Going to put wavelength down here, absorbance here, sample somewhere. We'll leave it here for now. And that's very important. I'm going to make this a line graph. We've never talked about line graphs yet, and that's because people misuse them terribly. You only use line graphs when there is a direct connection from like point A to point B um, between your variables or within your variable along an axis. So 90% of the time in our course, we make scatter plots. Really, the only time we make line graphs is when we're looking at spectroscopy data. All right, so now we have our spectroscopy data. We want to make use of the space. So clearly, this is the interesting part of the spectra. This should take up most of our graph, if not all of it. Uh, what's happening here is we're using organic solvents in this situation, and they absorb ultraviolet light. So everything below 350 does not make sense. Also, they don't really absorb above 700 or 750. So we're going to change this axis to measure from 750, 350 to 750. All right, okay, bam, there we go. Now, I like to just click and drag. So we're just going to go up here until our hand rotates, and we're going to adjust our absorbance until it takes up most of our graph. Play with this a little bit. Get rid of some of that. I guess we go all the way over to 700. And there we go. I'm going to leave the 1.5. All right, so now I have a couple options here. I can leave my sample as overlay. I can group it. I can maybe wrap it. Um, but I'm just gonna leave it on overlay. Now things get complicated. So fortunately, these come out alphabetically in an order that makes sense. I don't want too much information on here because as you can tell, there's a lot going on. It's kind of hard to follow. So I'm gonna start getting rid of some extra data. I'm gonna leave my blank on here because this tells me, okay, my blank measurement is good. And you can see that my blank measurement tweaks out in that's not right, breaks when we get into the ultraviolet. Uh, I like to color these sequentially so that they're a little easier to follow. I think the default hodgepodge is a little tough. So I'm going to do that using the value colors over here. So I'm going to make my blank boring. And then we're going to go with kind of a rainbow gradient of oranges here. I don't know if that made me happy yet. Um, I'm not loving it. So here's the next plan. We're going to pick one of these to focus on. Uh, yeah, I like that. So this, if you click on something in your graph, it'll highlight it. And then interestingly enough, if we open up a Google Sheet, which I will do, and try to export this into that sheet. So I'm just going to quick turn off the title, the footer. I know those will export funny. It'll, if I copy it using this format, I don't bother with the exporting. It'll copy it as it appears. So now I can see that fraction 2 is highlighted. Um, this is good for lazy stuff. I don't like that it highlights my blank over here. So in this case, I guess I would have to go through and change the transparency on all of these to, let's say, 0.2. So now we're looking at, say, fraction 2 here. We have a couple peaks. I want to highlight these three main peaks here. So the way I'm going to do that is just a little bit of guess and check. Ideally, I would actually go into the data and look at the maximum here. Why don't we do that actually? So we're looking at fraction 2. That's a pain. It's going to yell at me. All right, so now we want fraction 2 around 409. Let's see, so 410.5, we'll just call it 410, not a huge deal, is one of our peaks. So we'll add a line there, boom. Notice that we can't see that label because I didn't label it. Date. And then we'll angle this to see, and it's still too close. So we've got a peak at 410. This one I bet is 430 right now, 452. Let's scroll down, see where that peak is. So that one's a little farther. That one's at 455. Bam. And then lastly, we should have one right at 660. The oh, 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 oh. 64. Okay. There we go. And adding reference lines is really nice because it, like, literally it gives us a point of reference. So we can see that in this sample that a lot of our peaks overlap. So that kind of makes sense. This was from a column extraction of some pigments, and this pigment was mostly chlorophyll A and some chlorophyll B. So we have this is the chlorophyll A peak. Um, there actually should be a peak at 430 here, which is this back one. This one degraded into the, can't remember what degraded chlorophyll is called, but it loses that peak when it degrades. And then this peak over here is actually from our chlorophyll B. So is this one. So if I wanted to mark this 643 from fraction 4, so let's go over to 640 and find out where that peak is. The 0.44 is at 648. Bam. Hey, I'm looking at that right, yeah. Maybe we'll make this fraction a little less opaque back. So you can see here we have peaks coming out at 410, 455, 648. Ooh, these two labels are too close to each other, so we'll try angling it. That'll bring them back. And this is the key part. So we want you to just be able to come through and label these for us when you submit spectra. If you can tell us what they mean too, that would be great. Here you can see, if let's make all these back to 1. We'll tell the story of what's happening here. So we have a whole bunch of, what is degraded chlorophyll called? Phytin. Yeah, pheophytin. All right, so we have a bunch of pheophytin here. We see more pheophytin come out. See a little bit of chlorophyll B coming out. See less pheophytin, same amount of chlorophyll B, and now we see the big shift. So we see the pheophytin. We see this peak here. This peak is actually chlorophyll A and then chlorophyll B. So most of our pheophytin degraded. It looks like our chlorophyll A came out the tail end of it, and then we see just the gradual dilution of chlorophyll B as we run out of it in the column. So use this to look forward to during your plant pigments extraction. Hopefully you'll see something better than this. Not as troubleshooty. I was collecting fractions. You guys will have a goal. Uh, but this is my current preferred way of making the spectra is doing that multi-series stack and then working from there. It's much easier to work with them from this with them as this overlay rather than trying to plot a bazillion of them on the same axes. So with that, good luck guys. Thanks for watching and let us know if you have any other questions.